So in this video, I'm going to explain you that how you can capture audio using laptop's inbuilt microphone in single channel and multi-channel environment. Also, I will explain that how you can read and write the audio data in your computer. Also, I will explain you that how you can capture the audio signals from external musical source which is connected to your computer via the audio cable. So let's start our session. Here I am going to explain that how you can record your audio using laptop's inbuilt microphone in single channel. For this, first you have to define the sampling rate. Here I have taken 44.1 kilohertz, then number of channel, and then number of bits per samples. Here I have taken 16. The default is 8. You can give even higher, such as 24. And now define the audio recorder object which needs all this sampling rate, number of channels, and number of bits per samples. Then by using the record command, you can start your recording. Suppose you want to record for 5 seconds, then you need to execute pause 5 and then stop this object to stop recording. And to listen that what you have recorded, you can execute this play command. So let's see what happens in the MATLAB. So in MATLAB, I will execute all these commands one by one. So first the sampling rate, and then number of channels, and then number of bits per samples, and then defining this audio recorder object. So now I will execute the record, pause, and stop all the three simultaneously, so that my recording will be of 5 seconds. So I'm executing it. Hello, hello, this is channel 1. Hello, 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 hello. Okay, it's done. So let's see what I have recorded. So this can be listened by executing this play command, and let's listen what we have recorded.
Hello, hello, this is channel 1. Hello, 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 hello.
Okay, this is what we have recorded. Now instead of using this three commands, in fact record, pause, and stop, I can use the same thing with a single command, and that is a record blocking. So here in record blocking, we need to pass the number of seconds in the function. So for 5-second recording, just write 5 here. For 10-second, just write 10 seconds here. And after this, let play the recorded sound. So let's do this in MATLAB. Let me execute this record blocking. Hello, hello, this is by record blocking. Hello, this is record blocking. Hello, this is record blocking. Okay, it's done. So let me play this to listen that what I have recorded with this command.
Hello, hello, this is by record blocking. Hello, this is record blocking. Hello.
Okay, so this is what we have recorded. Now whatever we have recorded, that all is inside this recording object. You can see this in workspace. Here you are not able to see your samples, etc. So if you want to see your all recorded samples, you can see them. For this you need to execute a command which is get audio data. So just pass this recording object in get audio data. The whole samples will come in my recording variable in workspace. Then you can visualize them, you can plot them to see your waveform, and then you can listen also. So by the sound command, just pass the my recording variable and then sampling rate, then you can listen whatever we have recorded. So let's try this in MATLAB. So executing this get audio data, evaluate. So now you can see in the workspace that my recording variable is created and it has a total number of samples, right? And you can plot it to see the waveform, evaluate. So this is the waveform what we have achieved during recording. So this is my wave, my audio in waveform. I can play this variable also, my recording, but by the sound command. So let me execute this sound command and listen what we have recorded.
Hello, hello, this is my record blocking. Hello, this is record blocking. Hello.
Okay, this is what we have recorded. Now I will show you that how we can record our voice in two channels, that means stereo recording. So here we have to define the number of channels as 2. Let sampling rate remain same and number of bits remain same. Then we have to redefine the audio recorder object, then using record blocking for 5-second recording and then playing. So both the channels, 2 channels will be recorded, and you can get your audio data into my recording variable by get audio data, and then you can plot it. Since both the channels are recorded in my recording variable, you can separate them. So both the channels can be separated like this: channel 1, channel 2, and then you can plot them separately. And you can play any one of the channel also. You can play channel 1, you can play channel 2 like this. So let's try this in MATLAB. So first I will define the number of channels, that is 2, and then redefine the audio recorder object, and then I will execute the recording. Hello, hello, this is 2 channel recording. Hello, this is 2 channel recording. Hello. Okay, it's done. And let me see what I have recorded. So execute the play command.
Hello, hello, this is 2 channel recording. Hello, this is 2 channel recording. Hello.
Okay, this is what we have recorded. Now getting the audio data in my recording variable. Okay, so here in the workspace you can see that number of samples by 2. 2 means actually there are 2 columns, each representing the number of channel. So since we have recorded 2 channel sound, so that's why we are getting the 2 columns of the data in workspace. I can plot it by plot command. So this is my audio data which is plotted, but here both these channels are superimposed, so I'm not able to see them separately. Let me separate them. So channel 1 is separated like this, channel 2 is separated like this, and then I can plot the channel 1. This is channel 1. I can plot the channel 2. This is channel 2. So both the channels are plotted. This is channel 1 and this is channel 2. So both are shown separately, right? And I can play them also separately. So if I pass channel 1 in sound function, then you can listen
This
it.
is 2 channel recording. Hello, this is 2 channel recording. Hello.
This is channel 1 and this is channel 2.
Hello, hello, this is 2 channel recording. Hello, this is 2 channel recording. Hello.
Okay, so we have separated both the channels and we have listened both the channels. In this sound function, the sampling rate plays a critical role. So you need to specify the sampling rate properly, and it should be the same with what we have used in recording. So during recording we have used 44.1 kilohertz. The same should be used here during playback also. So if you use something else, then your playback will not be proper and it can be something horrible. For example, In the next command, I'm using just half of the sampling rate in playback, and let's listen what we get, what type of sound we get. Listen. Okay, this type of robotic sound we achieve. So you should be very careful when you specify the sampling rates during the playback. Okay, now let's read some audio files which are lying on hard disk of my laptop. So with MATLAB you can read those files. For example, that mysong.mp3 is a file which is lying on my desktop. So I can read the whole file into the MATLAB with this audio read command. So after executing this, you will get all the samples in variable y and the corresponding sampling rate of reading in fs. So let me do this in MATLAB. So executing this audio read. Okay, it's done. So my song.mp3 actually is a 5-minute song, and whole samples now are captured in variable y. You can see here, and since it's a variable, if you want to listen it, you can use sound command with proper sampling rate. So at this moment, if you execute sound command, there will be a problem. Although it will work fine, but sound is a uncontrolled command. So once it is executed, you will not be able to stop it until the whole song is played. So we do not want to listen here 5-minute song. So what I am going to do now, I will just read the first 10 seconds of this audio file. So for this, you need to define the number of samples corresponding to the 10 seconds by this. Then executing audio read again with these number of samples corresponding to 10 seconds. So by this you can record your mp3 song for first 10 seconds, and then you can listen by sound command. So let me do this in MATLAB. So first I will find the number of samples corresponding to 10 seconds, then executing audio read again for 10 seconds. So now this YC variable, it is a cropped mp3 file. Instead of 5-minute song, it is just 10 second song, first 10 seconds. So now we can listen that what we have recorded, so by the sound command. So let me evaluate it. Okay, this is the first 10 seconds of that song. Let me show you that song also on my desktop. So this is the song, my song.mp3. Okay, now in MATLAB you can write the mp3 files also. Okay, MATLAB has a facility to write the sound files by the audio write command. This even you can change the type of algorithm also. For example, the file which I read was mp3, and now I can convert that into mp4. So there are other extensions are also supported. You can take the help of MATLAB. So here by audio write, I am converting this mp3 into mp4. You have to specify the variable and the sampling rate. So let's try this in MATLAB. So now I am executing the audio write, evaluate it. Okay, it's done. So this file is written on my desktop. Let's see where it is. Okay, this one. So this is the cropped MP3, and you can see that extension is MP4 for this 10 seconds, right? You can also play it. Okay, so that was a recorded MP4 format. Now let us compare the play in sound command. As I said earlier, that sound is uncontrolled. Once it is executed, you cannot stop it. But play has the full control facilities. You can stop it, you can pause it, you can resume it. So let's see this with an example. But the problem with the play is that it cannot work with the array. You cannot play any array, but sound can play any variable from the workspace. So play works with the audio player objects. So for suppose you want to play a variable in workspace which is y with the sampling rate fs, then first you have to define the audio player object. Then just to play it, simply execute the play command, and to pause it, pause, resume, and then stop. So we can see this in MATLAB. So let me first define the audio player object. So it is executed, and now let me play this song by play command. So it is paused by pause command, and then it can be resumed from the same moment time instant. And then it can be stopped. So play is more flexible with lots of controls, while sound is uncontrolled. Till now I have explained you that how you can record your audio using laptop's inbuilt microphone. I also explained that how you can read and write audio file in MATLAB. Now I am going to explain you that how you can record audio from some external source. You can see in this figure that if you want to record the musical signal from your mobile phone via this 3.4 mm audio cable, then you can also do in MATLAB, but for this you need a data acquisition toolbox. So first of all, you need to execute this command .getDevices, because for recording audio from external musical source, you need to use the line-in port of your laptop. Why line-in? Because the music player gives audio output which is pre-amplified. So since it is pre-amplified, we don't need pre-amplification as in case of microphone. So we will use line-in port here. So and at this moment I don't know what is the device ID of this line in MATLAB environment. So first of all we need to execute this command. So once you execute this command, the MATLAB will show you a list of all the audio input output devices of your computer, from where you can find that what is the device ID of your line in. In my case it is audio 2. After that create a direct sound session and then add input channel with that device ID. So here I am using audio 2, means I am using line input of my laptop, and these are number of channels. 1 to 2 means I am recording in stereo mode, that means 2 channels recording. Then define the number of seconds for which you want to record, and then execute the start foreground. It means your once this is executed, your recording will be started, and the whole samples, recorded samples, will come in this data variable, in time will come in t. So you can plot it, and then you can separate both the channels, you can plot both the channels separately, and then you can play it using the sound command. As sound command needs sampling rate, so you can get the sampling rate of recording from this s.rate command. So let's see how this we can achieve in MATLAB. So before achieving this, let me connect my mobile with audio cable first. So my mobile is connected, and here I will choose the line in command, line in port. So my mobile is connected with the line in, and then I will execute this get devices. So here MATLAB is showing that my line in port has the device ID audio 2. Okay, so now I will create the data session. The data session is created, and then I will add the audio channel. The audio channel is added. Then I will define the duration of recording, that is 10 seconds. Now I will execute this start foreground. So before executing this, let me start playing the song on my mobile. So I have started, and let me execute here. Okay, so it is being recorded. You can see that MATLAB is busy right now, and okay, it's done. So now let me plot, so we can see that what we have recorded. So yeah, this is the song which I have recorded. So here you can see that the 2-channel recording, the channel 1 is shown by the blue, channel 2 is shown by the orange, and I can separate both the channels as I have explained before, channel 1, channel 2, and I can plot channel 1. So this is channel 1, and I can plot the channel 2. So this is channel 2. So both the channels you can plot separately, and now get the sampling rate of recording. So fs, now here you can see that fs is 44.1 kilohertz, and now I can play the song using this sampling rate. Okay, so let me execute it. Okay, so this is what I have recorded using the external music player device. So you can play both the channels separately, and now I will show you that how you can do the same things using MATLAB inbuilt application. So for this, go to this app tab of MATLAB, and from here find this analog input recorder and press it. Let's see what happens. So it's taking time. First time it takes time. So this is the window of this input recorder, and from this left side you can see the number of input devices again. So since I'm using line in so this is line in. So first you have to select the line in, right? So line in is selected, right? And now start playing a song from your mobile device. So mobile device is giving output. So here you can see the waveforms of audio, and it is a single channel right now. Now enable the second channel also. So this is second channel is also enabled. So both the channels are shown here in this window. Here this you can see the sampling rate, you can see the number of seconds for which you want to record. For example, I want to record for 5 seconds, so write 5 seconds, and here you can write your variable name. By default it is DAQ, so let me write DAQ, and then you can record it, right, using this red button. So just simply press it. Here you can see the progress, 60, 70, 80, 90 and 100. Okay, it's done. So recording is done. Now I can stop it, and then let me see where is the date, my variable. Yeah, this is DAQ is created here. So I can see that my all recorded samples are here, and since this data type is timetable, so I am not able to plot it. So I can convert this into array. by the command, let's say daq1 equal to table to array command. That is a table to array. The t is written 2 times, table to array daq. Let me see what happens. So now your timetable type data is now converted into double. Now you can plot it easily. So plot daq1. Okay, so this, okay, sorry, t is missing. So this is the song which I have recorded using that inbuilt application. And then what good thing with that application is that it can write code for you. For example, that you, when you press this generate code, it will write a file for you. So here in the notepad you can see that it has written in the same sequence for automatically. That means creating data session, a number of seconds, and then defining the or adding the channels, and then start foreground and channel separation, and then their plot. So this is what we have achieved automatically by this app. So you can use this application also, okay, for this session now.